Hello everyone and welcome to the lecture on AWS CloudFormation. So this lecture will be containing all these topics. First, what is AWS CloudFormation? Then some example code. Then what are templates, stacks and chain sets? How does a typical development workflow looks like using CloudFormation? Then CloudFormation stack sets. Building a continuous delivery workflow with code pipeline. This is one of the feature. And finally, working with AWS CloudFormation Git Sync, which is also one of the feature of AWS CloudFormation. So AWS CloudFormation, infrastructure as code. So if you know what is infrastructure as code, or you have worked with Terraform or some other infrastructure as code, then this does all the same things, and probably there's a like feature comparity. So there'll be like feature comparison. But in case you are aware about any infrastructure as a code, this should come easy to you, like understanding AWS CloudFormation. Okay, so AWS CloudFormation allows you to manage and provision your AWS infrastructure using templates. These templates can define everything from a single Amazon EC2 instance to complex multi-tier, multi-region applications. With CloudFormation, you can version control your infrastructure just like application code. This makes it easier to keep track of changes and manage your infrastructure more effectively. 3. CloudFormation makes it straightforward to replicate your entire production set for development and testing purposes, ensuring consistency across environments. 4th, you can create a JSON or YAML template that serves as a blueprint for your infrastructure and application stack. CloudFormation uses this template to provision and manage your AWS resources. You can define simple resources like Amazon VPC subnet or complex services such as AWS OpsWorks or AWS Elastic Beanstalk within your CloudFormation templates. So CloudFormation pretty much supports almost all the AWS services out of the box. So it is like because it's a tool dedicated to AWS cloud itself, and does not support any other cloud or any other infrastructure like on-prem or something. So it has coverage for 100% of all the services. I can say almost pretty much all the services. 6th, CloudFormation enables you to easily replicate your production environment for development and testing, which can be done with just a few clicks in AWS Management Console. You can keep track of infrastructure changes with CloudFormation templates. These text files allows you to see what resources are provisioned and their settings, facilitating easy rollbacks and updates. There is no extra charge for using AWS CloudFormation. You only pay for the AWS resources that are created and used by your application. So the resources that are created via AWS CloudFormation will incur a charge, but not the usage of AWS CloudFormation itself. Okay, this is an example code. So herein just an EC2 instance. So you just say that this is the property that this is how you refer. This is a logical name in the code. So if you want to refer it through S3 or something like S3 object, so there are resources. So you have name, logical name, then you say type. This is a standard predefined type. Then you what are properties that are required for EC2. So some may be mandatory, some may be optional. So we specify image ID, instance type, what key name we'll be using, and the EBS block device mapping settings we have provided to create this EC2 instance. Okay, next important feature are like templates, stacks and chain sets. So these are the actual building blocks of AWS CloudFormation. CloudFormation templates are JSON or YAML formatted text files that serve as a blueprints for AWS resources and describing details like EC2 instance configurations, which we have just seen in the previous slide. In CloudFormation, related resources are managed together as a single unit called a stack, which is defined by a CloudFormation template. So stack is basically, let's say you can assume like in a whole application, it can be just single resource like EC2, or it could be multiple resources which are grouped together in a single entity called stack. So they get either created or deleted at once. 3. When modifying a stack, chain sets provide a summary of proposed changes, which allows you to preview impacts on running resources and plan accordingly before updating. With stacks, you can create, update and delete a collection of various AWS resources. For example, auto-scaling groups, load balancers, databases, all of them together. Change sets help avoid unintended consequences like data loss when replacing critical resources by giving you a chance to review and prepare for the changes. So just before applying, it will show you on the screen what all will be changed and are you okay with it. And this will allow you a chance to see if you are by mistake deleting something or modifying something inappropriately. Let's say something is running in production and you don't want that to get modified. So basically it gets change sets allow you to see what will be changed before and after state, and you can make a final decision upon that. Okay, this is a typical deployment development workflow when working with CloudFormation. So when creating a stack, AWS CloudFormation makes underlying service calls to AWS to provision and configure your resources. So this is internal. So you before you apply it, AWS CloudFormation call these service APIs or the service calls to which all AWS resources you want to create or modify. And to execute these service calls, CloudFormation needs the appropriate permissions. These permissions are managed through AWS Identity and Access Management, AWS IAM, and you will need similar permissions in case you want to terminate instances when you delete stacks with instances or any other resources as well. When you need to update your stacks resources, you can modify the stacks template without creating a new stack and deleting the old one. To update a stack, create a change set by submitting a modified version of the original stack template, different input parameter values or both. CloudFormation compares the modified template with the original template to identify the changes. The change set generated by CloudFormation lists the proposed changes to the stack's resources, and after the change set is created, you can review the proposed changes to ensure they align with your expectations. If the proposed changes are acceptable, you can start the change set to update your stack with the modifications. And if you want to make further adjustments, you can create a new change set with additional modifications. When you delete a stack, you specify the stack to delete, and CloudFormation deletes the stack and all the resources in which are mentioned in that particular stack. Okay, next feature is CloudFormation stack sets. So we have seen stacks. This is stack sets, which is slightly advanced version of stack sets, and why they are advanced we'll see in this particular slide. AWS CloudFormation stack sets builds upon and extends the functionality of CloudFormation stacks. Stack sets enable you to create, update or delete stacks across multiple AWS accounts and regions. So this is the thing which makes a difference. It works with multi-account as well as multi-region setup. So stacks only is single account, single region limited, but this is across accounts and regions. 3. With stack sets, you can perform stack operations like create, update or delete with a single action. An administrator account is used to define and manage the AWS CloudFormation template. The template defined in the administrator account serves as the basis for provisioning stacks. So administrator account is, we are talking about AWS account. So you have a parent account or an account which we call as administrator account, which has all the privileges to not only modify resources in the administrator or the parent account, but also to be able to go to other AWS accounts or other AWS regions and be able to modify the resources in other accounts and regions as well. Stack sets allow you to provision stacks into selected target accounts across specified AWS regions. Okay. So when you use stack sets, you have the option to say which all region you want to target also, and you will give the AWS accounts that you want to target. Okay, building a continuous delivery workflow with code pipeline. You can use code pipeline to build a continuous delivery workflow by building a pipeline specifically for AWS CloudFormation stacks. Code pipeline is a AWS service. So code pipeline has built-in integrations with AWS CloudFormation, making it easier to incorporate CloudFormation actions into your pipeline. You can specify AWS CloudFormation specific actions such as creating, updating or deleting stack directly within a code pipeline. By including CloudFormation actions in your pipeline, you can automate the creation, updating and deletion of stacks as part of your continuous delivery process. Leveraging code pipeline and AWS CloudFormation together allows you to automate your infrastructure deployment process, reducing manual effort and increasing efficiency. So just to be clear, for some code project, let's say we have set up, for example, code commit, code delivery, code pipeline and all. So what we are doing with this tool is let's say we have set up a like CI/CD pipeline. We check in some code, then gets triggered, and then you trigger a code pipeline. And as part of that code pipeline action, you can create, for example, some dev or test environment, and that will invoke CloudFormation stacks and all. So you can create, update, modify or delete using the code pipeline. So basically it's a side effect, or not against side effect, it's an integration directly built into code pipeline. To basically as part of submitting a code, you can, let's say you committed a feature, it will just spin up a EC2 instance or whatever Kubernetes environment. It will deploy the code, it will test the code, and as part of the code pipeline itself, you can delete the whole stack in case you are satisfied with your code pipeline result. Okay, last feature is working with AWS CloudFormation Git sync. So Git sync enables managing CloudFormation stacks using a source control system, providing version control and collaboration capabilities. The CloudFormation template file and the stack deployment file. So you monitor the Git repository using the template file and the deployment file. So basically what is happening is CloudFormation can have a feature where it can monitor changes in your GitHub or Git repository, and it can see if it will look for a specific file called template file or deployment file, and if there are any changes, then it can trigger a CloudFormation template, and that will go ahead and update, create or whatever, do the CloudFormation stack. So the template CloudFormation template file contains the definition and configurations of the CloudFormation stack itself. The stack deployment file holds the parameter values used to configure the stack during the deployment or updates. So there are two files, one is template and the deployment file. So basically this you set in or you pass in some runtime parameter. So let's say you have environment equal to dev, production, staging. So you can specify in a deployment file, and both along with that. So just to make it more dynamic, when changes are committed to the template or deployment file, CloudFormation automatically updates the corresponding stack and streamlining the whole update process. With Git sync, developers can leverage pull request and version tracking capabilities of the Git repository for managing stack changes and collaborating effectively. So Git sync allows for centralized configuration and deployment of configuration stacks from a single Git repository, simplifying the whole development or the whole management process. So this feature is similar to something like I can say Terraform Enterprise, wherein that also has a feature to like checking your code or something, and that triggers the based on any changes. That triggers the pipeline, not pipeline, the creation of stacks or the infrastructure like Terraform. Let's say you are managing some other cloud provider like Azure or something, and you just submit, you check in the new code, Terraform code, and that automatically creates the infrastructure. So this is similar to that Git sync. And that's all. Thanks for watching.